Scientists from the Livermore National Laboratory have announced a major breakthrough in fusion energy research. Using a process called inertial confinement fusion, they have been able to initiate a nuclear fusion reaction that produces more energy than was needed to cause the fusion. In this video, I examine both the short and long-term implications this breakthrough has for addressing climate change. In addition, I will look at the economic and geopolitical consequences that would result from the successful development of fusion energy. The nucleus of a typical atom is made up of protons, which are positively charged, and neutrons, which are electrically neutral. So, two atomic nuclei having positive charges want to repel each other. Thus, if you want to fuse them together to form another nucleus, you need to supply enough energy to overcome the repulsive electrical forces. Stars like our Sun are very massive, so the gravitational forces are sufficient to overcome the electrical repulsion, and fusion of hydrogen isotopes into helium nuclei readily takes place, producing enormous amounts of energy, which leaves the star in the form of electromagnetic radiation. In inertial confinement fusion, very powerful laser pulses are used to compress a very small sphere of deuterium and tritium ice sufficiently to cause the fusion reaction to take place. Deuterium and tritium are isotopes of hydrogen. The nucleus of an ordinary hydrogen atom is just a single proton, while the nucleus of a deuterium atom consists of a proton plus a neutron, and the nucleus of a tritium atom consists of a proton plus two neutrons. The fusion reaction produces helium nuclei along with the emission of a significant amount of electromagnetic energy and some neutrons. In the Livermore lab experiment, the energy released in the fusion reactions exceeded the energy that was required to compress the sample of deuterium and tritium ice. This was a significant scientific achievement because it showed that it might really be possible to produce usable amounts of clean energy from fusion reactors. While the fusion breakthrough is interesting and may ultimately lead to commercially viable fusion energy production, that is unlikely to happen fast enough to have a major effect on the climate change that will take place during the remainder of this century. The reason for this is that even if feasible, the engineering hurdles that must be overcome to design, build, and test a viable commercial fusion reactor are daunting and could take decades. Then, if this effort is successful, additional decades would be needed to build and deploy them in sufficient numbers to produce a significant percentage of the world's electrical energy needs. The problem that we face between now and the end of the century is shown in the figure on the left. Basically, even if we meet current targets for reducing greenhouse gas emissions globally, we are likely to see somewhere around a 2.7 degrees centigrade global mean temperature increase by the year 2100. And an increase of that magnitude would have significant negative impacts on the daily lives of the inhabitants of the planet. If it turns out that by the end of the 21st century, clean fusion power has become a reality, and it has become possible to stop burning fossil fuels, then there is a good possibility that the global mean temperature will stabilize and very gradually start to decrease. The major problem that we face is that carbon dioxide and some of the other greenhouse gases already produced by burning fossil fuels will remain in the atmosphere for hundreds of years. If clean fusion energy becomes ubiquitous across the planet, the economic and geopolitical implications will be remarkable. Here are just a few possibilities. The fossil fuel industry may cease to exist, at least in its present form. Clean electrical energy could be produced in almost all countries. but robust electrical grids would need to be developed to ensure that energy needs are met everywhere. Hydrogen-based technology likely would then be developed for ocean and air transportation, and may actually become dominant for all transportation needs. I hope you have found this short video informative. Please post your comments and questions, and I will do my best to respond. Also, please take a look at some of my other climate-related videos. And if you haven't already done so, please subscribe to my YouTube channel.